Okay. And the next column from the left is the rank of that risk, and after that the kind of risk. Another one from the left is a description, and a description about that risk. After that, the category that this risk is belonging to that, and after that, root cause. It's about to finding the suitable response about that risk. Root cause of that risk. After that, triggers. The next column is potential responses for that risk. After that, risk owner. After that, probability of that risk. After that, impact or effect of that risk. Next one is severity or the risk number, and after that status or the situation of that risk. And at the bottom of the table there are some explanations that first row project severity or risk number is equal to expectation or probability from 1 to 10, multiply impact or effect from 1 to 10. It's an example for a project, and it's related to the example of software projects we discussed in last lecture, last session, last week. And I explained that we discussed that we must make a standard for probabilities and effects of risk in our project, in our risk management. It's an example. So project severity or risk number is equal to expectation or probability from 1 to 10, multiply impact or effect from 1 to 10. And next one is when should risk analysis be formed? It's a question. And it's not a time activity. It's not a time activity. And after that, periodic update and review about risk register. And in this example, calculating severity or risk number from the left, the first column is a problem. For example, SF. After that, late delivery of the hardware. In this example, after that, communication and network problem or problems. And the next column is expectation or probability, the number of 1 to 10. For example, for a staff, expectation or probability is number is 6. About the impact or effect of this item is 5 from 1 to 10, and severity multiplying 6 to 5 is 30, and about next item, late delivery of hardware, by multiplying 5 by 8, the severity or risk number in this example is 40, and for the next one is 21. And this explanation that project severity or risk number is equal to expectation or probability from 1 to 10 multiply impact 1 to 10. And about qualitative risk analysis, that is the third step of risk management process. Okay, engineers, any question until now? Any question? If your microphone has some problem, you can write your question.
No, Doctor. No question.
Okay, thank you.
Thank you.
Okay. About qualitative risk analysis, that is the Engineer Mohammed Jassim, please control your microphone. That is the third step of risk management process. First one, assess the likelihood or probability and impact or effect of identified risk.
السلام عليكم.
Assalamu alaikum wa rahmatullah.
Doctor, I'm sorry, the mic don't inactive.
Okay, thank you. How are you, Mr. Nores?
I'm fine.
Alhamdulillah. Thank you, Mr.
Thank you, Doctor.
Okay, thank you. Okay. About qualitative risk analysis, assess or determining or calculating the likelihood or probability and impact or effect of identified risks to determine their magnitude or amount and priority or ranking of that risk. Next one, risk quantification tools and techniques include first tool, probability or impact or effect matrices. Next one, the top 10 risk item tracking, and the next one is expert judgment that we discuss about its items. About to make the matrices of probability impact. The slash, that means or, is not quite here. Probability impact. Put together. Probability impact. We must write a dash between probability and impact. Probability impact matrix. A probability impact matrix or probability impact chart or table, because the matrix is a box like chart or like a table. A probability impact matrix or chart lists relative probability of a risk occurring on one side of a matrix or box or chart or table or axis on a chart, and the relative impact or effect of that risk occurring on the other side or axis of the chart. After that, list the risk and then label each one as high, medium, or low in terms of its probability of occurrence and its impact or effect if it did occur. And we can also calculate risk factor or risk numbers, numbers that present the overall risk of a specific event based on their probability of occurring and the consequence to the project if they do occur. If they do occur. Any question, engineers? Abdul Sahib? Any question? Okay. This video is a sample for probability impact matrix according to explanations, last explanations. From the left, there are probabilities in low, medium, and high levels, and in the horizontal axis that there are effects or impacts of risks, such as low, medium, and high amounts or levels. And in this example, there are with low impact and high probability risk number 6, for example. And for low effect and medium probability to occurring, there are the risk number 3, the example, and risk number 7. And there is not any risk in this example for low impact or effect and low probability. And for medium effect or impact and high probability, there is risk number 9. And with medium effect and probability, both of them, there are risk number 2, number 5, and risk number 11 in this example. And for medium effect and low probability, there are risk number 8 and risk number 10 in this region. And for high effect and high probability, that is very important and very dangerous or sometimes useful about positive risk or opportunities. For high effect and probability, that is very important. There are risk number 1 and 4 in this example. And for probability medium and effect high, there is not any risk. this region, and in this example, and with high effect and low probability, there is a risk number 12 in this example. So we can make such a probability effect matrix or table or box with our standards in our project, in our risk management process in a project. And in this example, this table sample probability impact matrix for qualitative risk assessment for Mr. Engineer Ali Habib.
يعني اثناء توقيت البريد او شيء هذا نقطة سلبية أو شيء ضدك صحيح سلبية عليك كل شيء هذا جاي واجب الحقائق غير كبير شيء يعني.
Okay. Sample of probability impact matrix for qualitative risk analysis. In the first part, that is probability of failure or PF, probability of failure, attributes of suggested technology. From the left, the value of probability, such as 0.1, 0.3, 0.9, and the second column from the left is maturity hardware or software. The next column is complexity hardware or software, and the last one is support base. And for example, for maturity hardware or software, by value of 0.1 is existing. After that, minor redesign for 0.5 major change visible, and for 0.7 complex hardware design or new software similar to existing. This is an example. Or for support base, by probability 0.1 is a multiple program and services, or for the probability of 90% or 0.4 for the number of probability, there is no additional programs. And the next table is about consequence of failure, or CF. Consequence of failure, the result of failure. CF. Attributes indicate of suggested technology. From the left and first column, like the last one is the amount or number of probability, 0.1 or 10%, 0.3 until 0.9 or 90%. The next column is fallback solutions. The next column is life cycle cost, LC or LCC. Life cycle cost factor or LCC factor. And the next column is a schedule factor or initial operational capability, or abbreviation is IOC, initial operational capability for a schedule factor. And the last column is downtime, or DT, downtime factor. For example, about fallback solutions with the probability of 10%, there is several acceptable alternatives. And for example, for about fallback solution in first column, for 70% there is some possible alternatives. And for example, about the schedule factor or initial operational capability, IOS, with for example 50% probability, there is 50 to 75% confident will meet IOC or initial operational capability. And for example, about downtime factor or DT factor, for 0.9 or 90% probability, there is a DT or downtime may not be reduced much. Okay. It's an example. And we can make a chart for this number by using probability and impact or effect of risk in our project or in our risk management. This figure is an example chart showing high, medium, and low risk technologies. In this chart, the horizontal axis is a consequence of failure, CF, probability, consequence of failure, CF, by numbers 0 to 1, and the vertical axis is about probability of failure, PF. So the horizontal axis is about the effects of any risk, and the vertical axis is about the probability of risks. And by multiplying effect to probability, we can determine or calculate the risk number. And according to these numbers, we can make some regions about the level or sensitivity of risks. So in this chart, we have 3 regions. We make 3 regions. In this example, we can make more than 3 regions for the level or sensitivity of risk in our project, in our risk management. The first region is about low risk with low effects and low probability. The next one, upper And the first is it's the region of medium risk with medium effects and probabilities. And the last region, upper region than medium risk, is high risk region for high effects and high probabilities of the risks. And about the risk, we can use this chart for determining the level of the risk or the risk number. The circles or points in the chart, the dark points are some risk with a determined probability and a determined effect in our project. And according the position of the point about any risk, that we can determine what the probability and effect of the risk. The region of the risk will be determined. For example, in low risk region or medium risk and high risk. But I think this chart has some problem. It's not enough, and it's not clear. Why? Because some risks that have low effects but high probability, they can be very important. And in worse, some risks that have low probability and high effect can be important. So this chart is not very clear. And by the matrix, I think we can analysis qualitative the risk in our project better than the chart. And we can use this chart for qualitative risk analysis in our project. Okay. Any question, engineers?
بلى دكتور. دكتور